back in geometry, you learned that if you had a circle and you had a very specific, say, radius, and you had an angle, that angle helped kind of create an arc. And we talked about arc length. And the variable for arc length that we're going to use is S. And today you're going to apply your knowledge of radians to help you out. And one of the classic applications is to arc length. And what you learned in geometry is to find arc length. You took the circumference. What's the circumference? 2 pi r. And you then multiplied that by a fraction. And it's like, well, what fraction would you multiply that by? Well, if you consider the circle, we're not talking about 360 degrees. We're talking about theta divided by 360, right? That's the fraction. So that's why when you came up with arc length, you multiplied by this formula, theta over 360. Now, you don't have to, just be honest. Do you remember that formula or not? Okay. And does anybody remember? Okay. All right. When I first started, here we go. So now you see where it comes from. Now what we're going to do is we're going to derive a new formula using radians. And watch what I'm going to do here, okay? 2 over 360 would reduce to what? 1 over 180, right? And in fact, I would have pi over 180. Everybody good with that? So I got rid of the 2 pi and the 360 there. I still have the r and the theta. I'm going to put the theta in front. I'm going to put the r back here. Hey, does theta times pi over 180, does that look familiar? That's how we convert from degrees to radians. And therefore, the pi over the 180 just goes away, and you're left with S is equal to r theta. So this is if you're in degrees. This is if you're in radians. And you can see that S equals r theta is a super easy way to generate arc length, isn't it? I mean, that's a lot easier than your other formula, 2 pi r times theta divided by 360. So we're going to use that. So flip your notes over. We're going to do this problem right here. Okay, example 7 says, find the length of an arc on a circle of radius 24 that subtends a central angle of 60 degrees. Right, and you don't like that phrase right there, that word right there. So we're going to make a circle. What's the radius? 24. What's the angle? And it subtends, okay, an arc. I mean, it just stretches over that arc. So that's the arc length that we would like to find. So what is my formula for arc length? S is equal to r theta. That's it. Do we know r? 24 times, do we know theta? No. And that's what you'll do on the test. So just grab 60. It doesn't work if you use degrees. If you want to use degrees, you got to use the one we gave you back in geometry, 2 pi r times theta divided by 360. But if you want to use this one, then just convert it to radians. Now it's easy, right? And what's 24 times pi over 3? 8 pi. Now, that's the exact answer. If you'd like an approximate answer, then go ahead and go to your calculator and just type in 8 pi, and you get 25.1. We'll go to the 10th there. And so that's approximation. So this is an approximation. This is exact. Your worksheet is going to ask you to do examples of both. Okay? Yeah? Not too bad, huh? Was that? If I ask you for one, I expect that you can do it. Okay. Another one, okay? That's S. If I ask for the area of a sector, that would be K. All right? So now we're going to look at sector area. And if we do that, area of a sector, I've got K is equal to, well, what's the area of a circle? Pi r squared, and I'm going to just do a fraction of that. What do you think the fraction is? Theta over 360. Now we're going to take that formula, we're going to convert it so that it's going to work in radians. So right now, this is if I'm working in degrees. Now you notice that in this one I had a pi over 180. Well, do we have a pi in this problem? Was it over 180? No, so I could rewrite it as k is equal to 1/2 times theta over 180. You agree that theta over 360 would be the same as 1/2 times theta over 180? Okay, so I got rid of that, and now I got pi times r squared. Well, I'm just going to use the commutative property of multiplication and say k is equal to 1/2 times r squared times theta times pi over 180. So I just put the pi up there, the theta on the side, it's fine. What, yes? Yep. Because that's your conversion from degrees to radians. Remember that if you have 60 degrees, you're going to multiply that by pi and divide by 180, and that's equal to pi over 3, right? So as long as if you put 60, you got to use that one. But if you put pi over 3, you've used that up. You've used it up, so it goes away. That's your conversion. So here, our pi over 180, that's our conversion, isn't it? So we can say, let's get rid of it. It's expressed in radians. And so k is equal to 1/2 r squared theta. We flip it over to the back side. It says find the area of a sector of the circle with radius 12 and a central angle of pi over 3. So I've got a radius of 12 and a central angle of pi over 3. What is my formula for the area of a sector? 1/2 r squared theta. What is r? Squared, 144. Do I have to convert pi over 3 to radians? No, it's in radians, isn't it? There's 2 times pi over 3. What's 1/2 of 144? 72. What's 72 divided by 3? 75 divided by 3 is 25, so 72 divided by 3 is 24. So we got 24 pi. And that's it. That's all I'm asking you to do today. We good? Okay, I've got a worksheet for you, and you could get it done during the hour.